Hey guys, I'm Robert, and in this video, I'm going to show you guys how to balance chemical equations. Let's begin. We have S8 plus O2, and it produces SO3. The first thing I would do is write down each of the element symbols. So we have S, and we have O, and I'm going to write these on the same order for the product side. So we know that we have S and O. Next, I'm going to write down how many of each of the element symbols we have. So we have 8 sulfurs. And we have 2 oxygens. And for the product side, we have 1 sulfur and we have 3 oxygens. And if we compare them, the sulfurs are not balanced, 8 and 1, and the oxygens are not balanced, we have 2 and 3. And for this one, the first one I would balance out is the sulfurs. If we look, we have 8 on the reactant side and 1 on the product side. So we know at minimum we're going to need at least 8 sulfurs on the product side. So I'm going to put a coefficient 8 here. And this 8 is going to sort of distribute to both the sulfur and the oxygen. So it gives us 8 sulfurs. But it also gives us 8 times 3, 24 oxygens. And if we compare them, our sulfurs are balanced with 8 and 8. And our oxygens are not balanced. We have 2 on the reactants and 24 on the products. So if I come up here to oxygen, put a 12. 12 times 2 is 24. Now we have 24 oxygens, and our oxygens are balanced. And if we check, our sulfurs are balanced, our oxygens are balanced. And here I'm going to add the coefficient 1. It's not necessary, but you can if you'd like. And our stoichiometric coefficients are 1, 12, and 8. And this equation is balanced. We have AU2S3 plus H2, and it produces AU plus H2S. The first thing I'm going to do is write down all of the element symbols. So we have AU, we have S, and we have H. Next, I'm going to write these element symbols in the same order for the product side. That way it's a little bit easier to compare. So we know we have AU, we have S, and we have H. Next, I'm going to write down how many of each of the element symbols we have. So we have 2 golds, 3 sulfurs, and we have 2 hydrogens. For the product side, we have 1 gold, 2 hydrogens, and 1 sulfur. And if we compare them, the golds are not balanced, the sulfurs are not balanced, but the hydrogens are balanced. And for this one, the first one I would balance out is the gold. We have 2 golds on our reactants, 1 on our products. At minimum, we need at least 2 golds on the products. So I put the coefficient 2 there. That gives us 2 golds. Our golds are now balanced. The next one I would balance out is the sulfurs. We have 3 sulfurs on our reactants, 1 on our products. So at minimum, we're going to need at least 3 sulfurs on the products. So I'll put a coefficient 3 here. And this gives us our 3 sulfurs. But this 3 also applies to the hydrogen. So it gives us 3 times 2 is 6. That gives us 6 hydrogens. And now if we compare, our golds are balanced, our sulfurs are balanced, and the last thing we need to do is balance out our hydrogens. We have 2 on our reactants, 6 on our products. If we put the coefficient 3 here, 3 times 2 is 6. That gives us 6 hydrogens. Now the hydrogens are balanced, and all of them are balanced. And I'm going to put the coefficient 1 here. It's not necessary to put a 1, but you can if you'd like. And our coefficients are 1, 3, 2, and 3. And this equation is balanced. We have FeCl3 plus NH4OH, and it produces FeOH3 plus NH4Cl. The first thing I would do is write down all of the element symbols. So we have Fe, we have Cl, we have NH4. NH4 is ammonium. Ammonium is a polyatomic ion. And if we check this equation, we know we have it on our reactants, but it's also on the product side. And when you have a polyatomic ion on both sides of the equation, it's easier just to balance as a whole. So I'm going to write the ammonium just as a whole here. And then we have OH. OH is hydroxide. Hydroxide is also a polyatomic ion. And if we check this equation, we know it's on the reactant side, and the hydroxide is also on the product side. So I'm just going to balance the hydroxide as a whole. So I'm going to write OH here. And now I'm going to write these elements on the same order for the product side. So we have Fe, we have Cl, NH4, and OH. Next, I'm going to write down how many of each of the elements we have. So we have 1 iron, 3 chlorines, 1 NH4, and 1 hydroxide. On the product side, we have 1 iron. Here we have 3 hydroxides. We have 1 NH4, and we have 1 Cl. And now I'm just going to compare them. Our irons are balanced. Our chlorines are not balanced, so I'm going to put an asterisk here just for a reminder. Our NH4s are balanced, and our hydroxides are not balanced, so I'm going to put an asterisk here. And we know we have 3 chlorines on our reactant side and 1 on our products, so at minimum we need at least 3 chlorines over here. So I put the coefficient 3 there, and that gives us 3 chlorines. But that 3 also applies to the ammonium, so that gives us 3 ammoniums. Next, I'm going to balance out our hydroxides. We know we have 1 on our reactants and 3 on the products, so we need at least 3 hydroxides on the product, on the reactant side. So I'm going to put the 3 here, and that gives us our 3 hydroxides, but it also gives us 3 ammoniums. And if we compare, we have 1 irons, our irons are balanced, our chlorines are balanced, our ammoniums are balanced, and our hydroxide are balanced. And our coefficients would be 1, 3, 1, and 3. And this equation is balanced and you're good to go. I want to thank you guys for watching this video. I hope it helped out some. Please hit the like and subscribe button, and peace.